Yes, tangent lines are related to circles in a roundabout way. So here we go. What is a tangent line? What we're talking about specifically is the fact that the derivative at a point is the slope at that point. Like duh, right? By definition. This means that it touches the graph at that point only once, typically, right? So for any given point, there's going to be a single value for the derivative. So if we think about that, and if we can talk about how we approximate the derivative too. So for any graph, a radius of curvature can be used to approximate the graph at that point, which means you could draw a circle in that means that the derivative at that point touches the circle represented by the radius of curvature only once. And as we know, if it is then hitting the circle only once, it makes it tangent to the circle. So then the derivative of a point can be used to write the equation of the line that has the same slope as the derivative, because the slope and the derivative are the same thing really, right? And passes through that point. This can be useful to easily predict values around that point if it is tedious or difficult to find the derivative of a particular function. Now that's a mouthful. So it's probably going to be good if we take a look at an example. So what I've done is set up a curve, specifically this purple curve here, right? And we'll call that function f of x, let's say. Now I need to dress this up just a little bit in that should be f of x sub 1, because that's the point x sub 1. So it's a fixed point, which means that the derivative is actually f prime of x sub 1. So what does that mean? If I were to look at that point, x sub 1, f of x sub 1, x sub 1, f of x sub 1, it's a point, right? At that point, the slope is equal to whatever f prime of x sub 1 is. Remember, you plug that value in, it's just going to be a number. So if I wanted to draw or figure out what that line was at that point, I could write something in, drum roll, point slope form. In other words, I could write a linear equation in point slope form. Why point slope? Because what? I know the slope. I know a point, and so that makes it easier to do. So it would be y minus f of x sub 1, that is the y value at that point, right, equals f prime of x sub 1 times the quantity, that's the slope, right, x minus x sub 1. I know, a little bit anticlimactic, right? But that would be then the equation for that green line. That's what that would be. And that is the tangent line. It is a line tangent to the graph. And that is my cat knocking over something. Now, ready, set, I should say one of my cats. We have 8, so one of my cats. All right, so an example. Let us say that we have this following information, which looks horrible, doesn't it? Here's the function, g prime of 2, g prime of 2 equals negative 3. What is that? That means the slope at x equals 2, the slope is equal to negative 3, right? That's what that means. And g of 2 equals 8. G of 2 equals 8. This is not g times 2 equals 8, which means g is 4. It means that at the independent variable 2, at the value of the independent variable of 2, we get the whole function, the output being 8. So in other words, this is the point 2, comma 8. So using this information together, we have a slope and a point. We can write the equation for the tangent line, which is actually, write the equation at x equals 2. So what we're going to do is write that. How? Y minus the y value, aka 8, equals the slope, aka negative 3, times x minus, now remember, it defaults to minus because it is a transformation, so positive becomes negative. Don't forget that. That'd be silly to screw that up. Now then it says use this to predict the value of g of 2.01. Now we don't know anything about this function except that it hits this point and it has that slope at that point. So this is where we can only predict using this, well, tangent line. So is 2.01 really close to 2? You bet, a little bit farther. Prediction at 2, at x equals 2, y is equal to 8. And the slope is negative 3. So what we would expect is the function would get smaller. That is, we would expect g of 2.01 to be something that is less than 8. And let's see if we're correct in our assumption. The reason is because the slope is negative. So to figure out g of 2.01, we're going to, well, we're trying to figure out the y value. 8 doesn't change. Negative 3 doesn't change. X changes to 2.01 minus 2. What did we do? Well, we plugged the x value in, and now we're going to predict the y. So we know y minus 8 equals order of operations, right? So y minus 8 equals negative 0.03. So, I'll scroll down just a little bit. Add 8, y equals, well, negative 0.03 plus 8, 7.97, which is slightly less, which makes sense because it's decreasing. It's slightly less because we only gone slightly farther over, right? We increase slightly the x, the y value decreases because the slope is, at x equal 2 is negative. Should probably write that down. In other words, our answer makes sense. Okay, so now let's try something where we combine our knowledge of the power rule and the tangent line. Okay, for this function, find the equation of the tangent line at x equals negative 2. Then use the tangent line to estimate the value of f of negative 1.5 and then compare this to the actual value. Okay, there's a lot of stuff going on. So first off, we're going to need the slope at a point, which means we're going to need the derivative, which means, well, look, power function, power rule. 2 times 3 is 6, and x drops a power. Minus, well, we know that becomes what? Just 5. So now what we can do is figure out what f prime at our target value, negative 2, right? Target value is by doing 6 times negative 2 minus 5, which is negative 12 minus 5, or negative 17. Negatives, let's clean that up, make it look like a negative 17. Bye-bye. 17. Better. Okay. What else do we need? We've got the slope. So the slope, this is the slope, right, at that point. Well, what do we need next? We need the actual value. So we're going to have to figure out f of negative 2. How? Oh, wait, we've got the function. 3 times negative 2 squared minus 5 times negative 2 plus 7 is, well, f of negative 2 then is 3, negative 2 squared is positive 4, minus 5 times negative 2 is negative, so that's going to be plus 10 plus 7, which is 12, plus 10 plus 7 is 39. So we know that f of negative 2 is equal to 39, right? Okay. So now what we can do is we can write the equation for the tangent line using that information. And it's a matter of, I'm not going to say plug and chug per se, but it's not that bad. So tangent is the y value. Now it's positive 39, so it's going to become minus 39, equals the slope, which was negative 17, plus 2, right? Okay. So let me just clean that up because we had a little bit of a computer glitchy there. Good. So that would be the equation of the tangent line. So how could we use the equation of the tangent line to predict f of negative 1.5? So this is the predict, right? Predict. So what we do is y minus 39 equals negative 17 times negative 1.5 plus 2. Now I'm going to save you the grief, embarrassment, shock, and horror of all this by taking and doing this on my calculator. So I'm going to take negative 1.5 plus 2, which is 0.5. So 0.5 times a negative 17 is negative 8.5. And then I'm going to add 39. So 39 plus a negative 8.5 is 30.5. So the predicted y value, this is predicted, y is equal to 30.5. I'll just run the numbers here. So 0.5, half of that, 8.5, right? That's negative. Yep, okay. So that's the predicted. And then it says compared to the actual. Well, in this case, we actually know the function. So could we just plug in, this is the actual, right? Plug in negative 1.5 into that equation. and figure out what it actually is. Now you say, why the heck do we do the predicted? Well, let's see how close are we. Why not, right? Negative 1.5 squared minus 5 times. I'm just writing this out because I'm going to use my calculator again. I'm not cheating per se, but saving myself some calculation time here, right? To show you how I'm getting it predicted. So 3 times negative 1.5. Well, I know negative 1.5 squared is going to be positive, so 1.5 squared minus negative, so plus 5 times 1.5 plus 7 is 21. So the actual f of negative 1.5 is actually equal to 21.25. So it turns out that we have a gross underestimate or overestimate of what the value is. So that means that at that point that function is changing pretty fast. But hey, it does have a tangent line that the slope is negative 17, so it's decreasing, but quick, right? But that's an example of how we did that. So we used the function to find the derivative, plugged the value in to find the slope at that point, the derivative at that point, plugged it into the equation again to find the point, made a tangent line, and then went to town. Not literally. That's it.